Welcome to our lesson on quadrilaterals. So a quadrilateral is a four-sided polygon. And here are some examples of quadrilaterals. It's pretty clear that these all have four sides, and of course they don't need to be equal to each other. It doesn't need to be a regular polygon for this. This is not a quadrilateral because you have five sides. And this one's also not a quadrilateral because you have a rounded side. So here are some different types of quadrilaterals. The first one is a trapezoid. So this name over here. And this is when you have one pair of opposite parallel sides. So these are the parallel sides that they're talking about. And all you need is one set of them. The other type is the isosceles trapezoid, so one pair of opposite parallel sides and another pair of opposite sides that are equal length. So this one over here is your isosceles trapezoid because not only do you have those two parallel sides, but these sides are equal to each other. And you also have equal angles as well in the corner. And this is just a typical trapezoid with only one pair of opposite parallel sides. Notice that parallel is denoted by a little arrow, and you have two sets of them. If you see that, that just means that this is parallel. This next one here is a parallelogram. And our opposite angles are equal, so these angles are equal, and also these angles are equal. So the one with the one loop, those two are equal to each other, and the other ones with two loops are equal to each other as well. The other property of a parallelogram is that diagonals bisect each other, but they're not equal in length. So remember, a diagonal is from one vertex to the other vertex. So it looks like this. Just saying that these two blue lines, dark blue lines I just drew in, bisect each other, but they don't equal length. Another property is that two pairs of equal opposite parallel sides. So here, I'll do another color. These two lines are parallel to each other, and these two lines are parallel to each other. So the ones on the top and the bottom are parallel, and the ones on either side are parallel. And I just denoted it by two little arrows to indicate that these two lines are different from the one from the top and bottom. The other shape you're very familiar with is a rectangle. So two pairs of equal opposite parallel sides. So these two lines are equal to each other. They have the same length, and so do these two. I'm just denoting that their length are equal to each other. And all angles are 90 degrees. Diagonals are of equal length, and diagonals also bisect each other. So I'm going to draw another rectangle here to show you what I mean. Here are your diagonals from one vertex to the other. So these two lines are equal to each other. And of course, you can see that they bisect each other, means that they cross each other. The next one here is a rhombus. So in a rhombus, all sides are equal to each other. That means that all these sides are going to be either 2 centimeters or 9 centimeters or whatever it would be. Also, opposite angles are equal. So this angle is equal to this angle, and this one on this side is equal to the one directly across from that. Also, the diagonals are perpendicular bisectors, but they're not equal in length. I'm going to draw another diagram to show this. So here's another rhombus. Our diagonal are drawn by connecting the vertices on each side. So it's saying that they're perpendicular. This means this creates a 90-degree angle like that, all the way around. But they're not equal in length. So only thing it creates is a 90-degree angle between each. diagonal. The next one you're familiar with as well is a square. So all sides are equal to each other. And you're going to have 90-degree angles for each angle. All your diagonals are equal in length, and they're also perpendicular. So here's your diagonal. Your two diagonals, these two are equal in length. And they all also create 90-degree angles. I know it doesn't really like it in my drawing. It's just because I didn't draw a perfect picture, but they should be perpendicular. That should create 90-degree angles between each diagonal. And then lastly, we have the kite. So we have two pairs of equal sides and one pair of equal angles. So usually these two angles are the ones that are equal to each other. And the two pairs of equal sides could either be these two or they could be these two. Do they have to be? No. You're going to have perpendicular diagonals, one of which is bisected by the other. So here's your diagram. I'm going to redraw a kite. And your diagonals look like this, like a cross. And there's just saying that these are perpendicular, so they create 90-degree angles. Now, some of the properties you can think about are the similarities between a rectangle and a square. So technically, a square can also be a rectangle, but a rectangle can't be a square. The reason being is that a square can be a rectangle. It just has all the sides equal to each other. Your diagonals are still equal in length. You still have 90-degree angles, and you still have bisected diagonals. So a rectangle can't be a square because a rectangle will never have all equal sides. So I'm going to add this in the notes that a square is a special rectangle. And then when we look at parallelograms, it's very similar with the rhombus and the parallelogram. A rhombus is a special type of parallelogram where all sides are equal. And not only is a rhombus a parallelogram, but so is a rectangle and a square. Nowhere does it say that a parallelogram can't have a 90-degree angle. It certainly can. A parallelogram just needs to have parallel sides and two pairs of them. So a rectangle certainly has that, and so does a square. So these are also parallelograms.